Physics part 42. 22 kilometer, 22.2 into 10's power raised to 4 meter. In 1 hour, 3.6 into 10's power raised to 3 seconds is an average speed of 6.1 meter per second, seconds power raised to -1. 11 minutes is 660 seconds. Since average speed is the distance covered, time taken, the distance covered is given by average speed, and time taken is or 6.1 into 660, which is equal to 4,000 meter. Note that the important working in consistent units, this is why average speed and the time were converted to meters per seconds, seconds power raised to -1 and s respectively. A train is traveling at a speed of 25 meters per second, seconds power raised to -1 along a straight track. This is our example number 3. Train is traveling at a speed of 25 meters per second, seconds power raised to -1 along a straight track. A boy walks along the corridor in a carriage towards the rear of the train at a speed of 1 meter per second, seconds power raised to -1 relative to the train. What is his speed relative to Earth? In 1 second, the train travels 25 meters forward along the track. In the same time, the boy moves 1 meter towards the rear of the train. So he has moved 24 meters along the track. His speed is relative to Earth is 25 minus 1, 24 meters per second, seconds power raised to -1. Now it's your turn. The speed of an electron in orbit about the nucleus of a hydrogen atom is 2.2 into 10's power raised to 6 minutes per second, seconds power raised to -1. It takes 1.5 into 10's power raised to -16 per second for the electron to complete one orbit. Find the radius of the orbit. Number 2, the average speed of an airliner on a domestic flight is 220 meters per second, seconds power raised to -1. How long will it take to fly between 2 airports on a flight path 700 kilometers long? 2 cars are traveling in the same direction on a long straight road. The one in front has an average speed of 25 meters per second, seconds power raised to -1 relative to Earth. The other is 31 meters per second, seconds power raised to -1, also relative to Earth. What is the speed of the second car relative to the first when it is overtaking? 3. Next, we've got speed and velocity. In ordinary language, there is no difference between the terms speed and velocity. However, in physics, there is an important distinction between the two. Velocity is used to represent a vector quantity, the magnitude of how fast a particle is moving and the direction in which it is moving. Speed does not have an associated direction. It is a scalar quantity. So far we have talked about the total distance traveled by a body. Like speed, distance is a scalar quantity because we do not have to specify the direction in which the distance is traveled. However, in defining velocity, we introduce quantity called displacement. Displacement of a particle of its change of position. Consider a cyclist traveling 500 meters along a straight road and then turning around and coming back 300 meters. The total distance traveled is 800 meters, but the displacement is only 200 meters. Since the cyclist has ended up 200 meters from the straight point.